So something we've alluded to, but we will now explicitly show, are the different flags in TCP. If you look in the TCP header, there are 4 bits. Each bit corresponds to one of these flags, and you can set the bit to 1 or 0 to indicate some special things you want to do. If you want to send your initial sequence number, you'll turn on the SYN flag, and that says, this packet contains my initial sequence number. So write this down. This is where I'm starting. This is why, if you look at the TCP handshake, which I'll try to find, you can see that these 2 packets have the SYN flag turned on. It's because they are the client and the server indicating their initial numbers. Back to the flags. If you turn the ACK flag on, it means that whoever's receiving your packet should read the ACK number because you're indicating that you received something and you want to tell the other side. So if you turn this flag on, you're basically saying, read that number in the ACK. I'm telling you I received everything up to and including this byte. If you turn the ACK flag off, you're saying that those bytes are garbage and you're not acknowledging any packets, although that doesn't really happen when you're sending data back and forth. And we saw fin and reset, which are the nice and the rude ways to finish a connection. Fin says, I'm no longer sending, but I'll receive. Reset says, I'm not sending and I'm not receiving. So those are the 4 flags that we care about. There are some other ones that we haven't talked about. So here's the entire TCP header. Don't need you to know all of it, but a lot of it is stuff we've already seen. We've seen that there are now port numbers, source and destination port. The source port, for example, would be the port number on my computer if I'm sending a packet, and the destination port would be a fixed, well-known number on the server that I'm talking to. For example, 80 for HTTP. And in the reply, the 2 numbers would be swapped. It would be coming from port 80 to my randomly chosen port number. These 2 numbers we've talked about. The sequence number stamps the packets that I am sending. So if this is byte number 20, I would put number 20 in the sequence number. And the acknowledgement number is for me to acknowledge data that I received from the other side. So if the other side sent me packets 100 to 110, then I would put the number 111 here to indicate that the next byte I want from you, the other side, is 111. We will not talk about this. The flags are SYN, ACK, fin, and reset, and there are some other ones that we don't care about. And there's also a checksum to detect corruption. I guess this one we haven't explicitly called out yet, but the checksum, maybe I even had a slide about it, is for checking if things are corrupted. Here. So if a packet gets corrupted in transit, say there's a random bit change that was not expected, we'll add a checksum just to make sure that everything is untampered with. One thing to note is that the checksum is not a cryptographic function. There is no secret key. There's no cryptography. It's just checking that the bits have not been randomly tampered with. So this will not stop an attacker. Anybody can compute checksums. It's just there to protect against unintended random corruption, and it's not protecting against intentional attacks. So that's the checksum, and we will not talk about urgent pointer, and then there's a bunch of data that you can send as part of the TCP payload.